worked with yesterday. Let's see if I can put all this in a table, and I think for the past, when I tried this with some classes in the past, they appreciate it. They can just look at a table. If I ask you to find the sine of 30 degrees, boom, 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 in the table they see it. Or cosine 45 degrees, they can just follow the table. So guys can see what this table is going to look like. And here we go. I think this will be a good way to summarize all this. Like a fairly good sized table to put everything in here. The way I have this table labeled, constructed here, yeah, I need this. Divide this up. See if this will work out for us. Space there on the end there for a reason there. Guys, what we'll do is, I've labeled my table like this, and let's put everything together. I want quadrant 1 represented here. Quadrant 2 represented here. Quadrant 3. And of course, quadrant 4. Down here. There's my 4 quadrants. Let me list also right there with those quadrants in this table the associated signs with the point that may fall in that quadrant from algebra 1. So if you plot a point that falls in quadrant 1, we're guaranteed the coordinates are both positive. That's going to play a part with us. If I'm in quadrant 2 on a sheet of graphing paper and you plot a point that falls in quadrant 2, we're guaranteed it's what? Negative, positive. Quadrant 3, negative, negative. Will play a big part here. Quadrant 4, positive, negative. Okay, so we'll start out with that. And I thought in doing the table, what else should I include here? Well, here we go. In quadrant 1, I place these angles. 5 or 6, 5 or 4, and I threw in 5 or 3, which I did not discuss yesterday. I want to see what's going to happen here. And then on the side of each one of these, on the outside of the table for a reason, I'm going to place, use different colors here. Can anyone remind me what was the associated point in quadrant 1 for 5 or 6? That's the one we went through and actually derived what the coordinates should be that corresponds with 5.
3 divided by 2.
Here we go.
Square root 3 divided by 2.
Radical 3 over 2, and
1 half.
thank you. Exactly what I want. Guys, this red marker is not the greatest, but make sure you can see it. That's associated with 5 or 6. Now, does anyone recall, I think also we discussed what point is associated with 5 or 4?
Square root 2 divided by 2.
Absolutely. Radical 2 over 2. Radical 2 over 2. Now, this one down here, I did not do for you. By the way, if you want to convert it to degrees, this is 60 degrees. But I did not do it with you yesterday to find the corresponding coordinates for it. Some of my students may know though. Does anyone know?
1 half.
It is 1/2 for the x, and radical 3 over 2 for the y. So if you know this one, you'll know this one. If you know the one that corresponds with 30 degrees or 5 or 6, you'll know the one that corresponds with 60. That's going to play a part here. Now what else did I do here in the table to help us out? Let's see. We can do it. Okay, quadrant 2, quadrant 3, quadrant 4. Okay. Now, what I need with your help, make sure it's going to work out nicely. Here we go. I'm going we'll go through each one of the quadrants. Now, if you start out with 30 degrees, that's pi over 6. And some of my students, in fact, I think I did this one with you guys. By the time we moved to quadrant 2, right here, with 30 degrees, as a reference, we use that word reference. Anyone tell me what size was that angle over in quadrant 2? That had that reference of 30. And you remember I moved that 30 and asked students what the size of the angle might be. And then we went down to quadrant 3 with that 30, and then quadrant 4. Does anyone recall what size angle was it associated with 30, pi over 6, in quadrant 2? There we go. It is 5 over 6. Now, if you guys like degrees, it's 150 degrees. Now, can anyone tell me if I take this 30-degree angle and I go now into quadrant 3? I'll move it down to quadrant 3, and all together, can anyone tell me the size of that angle? Is it like 180 plus what? 30, what's that, 210? So if you convert 210 into radians, you can use a conversion factor, but I hear, Joseph, tell me again. How much? I heard 7 pi over 6. 210 degrees. And finally, if you move all the way to quadrant 4, and I think this is the one I looked at with you guys yesterday. What size angle was it when you finally get to quadrant 4 and using for a reference 30 as 30 is being moved? Was it like 330? I think it's 330 degrees. And in radians, Joseph, help me out. 11 pi over 6. Watch what's going to happen here shortly. Now let's do the same thing for 45. Pi over 4 is equivalent to 45 degrees. Now I may not have done this one with you. Anyone tell me if you take 45 degrees into, let me show you what I mean here, into quadrant 2. Yep, I'm hearing already. Right here is 45 degrees, pi over 4, or 30 degrees, and you take this over into quadrant 2. Anyone tell me what you think the size of that angle there is? What, 3 pi over 4 up here. 3 pi over 4, that's in quadrant 2. Now, for the sake of this table, let's take that 45 now, start here again, but this time move it into quadrant 3. You want to know what size that angle might be? 5 pi over 4, 225 degrees, because this right here is 180. So I'm adding 45 more to it to get down into quadrant 3. In radians, that's 5 pi over 4, I'll put it here. And finally, quadrant 4, I start with 45 again, and I move it into quadrant 4, like this, guys. Now it looks like that. What might the size of that angle be? I'm hearing 7 pi over 4, I think, what, 315 degrees, if you like degrees, 315, or 7 pi over 4. Right here. Now through the last one that I'm interested in today. Pi over 3, that's equivalent to 60 degrees. Now this is one that's a little new. Does anyone think they know what 60 degrees moved over to quadrant 2 as a reference would give me what size angle over there? 2 pi over 3, it's 120 degrees. How about if I move that 60 degrees, not 45, it's not 60, and I go down to quadrant 3? 4 pi over 3. That's 200 what, 240? And finally, if I take that 60 and take it all the way into quadrant 4, what might that size of that large angle there be? In quadrant 4, if I take the 60 into quadrant 4. Was it 5 pi over 3? I'm all in radians. You say, Professor, how's that going to help me? Okay? And when you move from this class into Math 7, Math 8, so forth and so on, most instructors will stick with these because these are key angles to work with. They're not going to ask you to find, I don't think, unless they allow calculators, a sine of 10 degrees or a cosine of 32 degrees. They want to try to stick with these key ones here that we're looking at. work with. Guys, you say, what's going on, Professor? And now underneath here, I want to ask you a few questions and see if we can match up some things in this table, which might help us. I did this. Go that way. Let's see if that table's gonna work out for me. I left a little space there. Sine of 5 pi over 6. That would be my first question. I'd like to know the value of sine of 5 pi over 6. A little reminder from yesterday, sine's definition was on the unit circle what? Does anyone recall what sine's definition was? It's y. So what's this ask me to do? Please go to 5 pi over 6. You say, Professor, right there it is. In the table. And you want the y, right there, the y must be positive. And what's its reference? This red one. And the red one have for a y what? 1/2? So all that together will give you what? Positive 1/2 here as the value of sine of 5 pi over 6. Just matching things up here. Let's throw in another one here. We'll get used to this table idea. I don't think your textbook is this of a table. I thought it could do it though. Let's try cosine 5 pi over 6. Now guys, I'm going to treat this one a little differently. You sort of see what's going on though. Cosine of 5 pi over 6, yes, 5 pi over 6 is in my table somewhere. Well, right there it is again. I'm looking for cosine. The definition is x. That's for cosine. 5 pi over 6, the x this time is negative. And it's negative what? The x here. It's reference. So it's a negative radical 3 over 2. And you're finished. Yes or no? Does it make any sense the way you're matching things up here? Okay, that's number 3. Trying to get everything sort of down in the table here that we talked about yesterday. I'm looking for sine of, I'm going back to sine, of 5 pi over 4. Okay, so Professor, 5 pi over 4, we have it in the table right there it is. And again, sine's definition is y, let me point that out. So I'm looking at the y coordinate, 5 pi over 4, the y coordinate right above here is negative. And guys, it's negative what? What's its reference? The reference right here is red. This point is acting as a reference. So it's negative radical 3 over 2. Not radical 3, radical 2 over 2. Do we agree? So I'm just matching things up here. How can you go wrong? Can't go wrong. Excellent. 4. I'll try some others here, guys. Hang on. Tangent of 4 pi over 3. And 4 pi over 3, yes, right here it is. It's in the table. Tangent's definition from yesterday was place the y over the x. You must know your definitions. So guys, here's 4 pi over 3. If I place the y over the x, that's the y, that's the x. Ends up with a negative over a negative, which turns into, for my answer, what? Positive. And what is that y over x will look like at 4 pi over 3? There it's just reference. I'm placing radical 3 over 2 over 1/2. So radical 3 over 2 over 1/2. 2's cancel. You guys agree? Is this helping? Is this helping the way we match things up, especially one of these little reference points here? Number 5. Make some sense of this. The next one looks like this. I threw in secant. 7 pi over 4. And I know secant's definition, and you know secant's definition. It's 1 over x. Guys, 7 pi over 4, take this, it's right here. It's in the table. Look right above here, if I'm placing 1 over x, well the x is positive. So I've got 1 over a positive, which tells me the answer is going to be positive. And what should that answer look like? Well, 7 pi over 4, its reference is this word here. So I'm placing 1 over the x out there in the red was radical 2 over 2. Yes or no? Does anyone know what that looks like cleaned up? Because you know you can't leave that radical in the denominator. Does anyone think they know what that would be after you cleaned it up, simplified it?
Radical two.
Just radical two?
Over two.
Just radical two?
Just
Will the twos cancel? Look at this, got you. One is being divided by, I'm hearing it, radical 2 over 2. That's the same as 1 times, flip this over, for me reciprocal. Is that true, guys? And then you know you can't leave that radical 2 there, so you say, Professor, I need to rationalize, I need to multiply this by radical 2. If I do, I'm going to end up with 2 radical 2 in my numerator. These 2 will give me a 2, radical 4, and will the 2's eventually cancel? Yes or no? So after all that work, my answer is radical 2. Or secant of 7 pi over 4. Woo! Yes, no? Now, am I going to have this table drawn for you on the exam? No. No. And if you like this table and you want to draw it real quickly on scratch paper or somewhere and make use of it, go for it. Okay? And could I add more to this table? I could. But these are the 3 major ones here. Guys, I got 30, 45, and 60 to work with. Now, it looks like on that table, let's see if I did. Oh, yeah, I did. Number 6. I'd like to find the cosecant of this. Where I know the cosecant from yesterday's definition is that. Call that number 6. Now, my students are looking at that table and say, wait, Professor, you messed up. I don't see pi over 2. I don't see pi over 2. But you saw it yesterday. Can anyone tell me the ordered pair is not in my table? It's not one of those 30, 45, or 60. Philip, tell me what's going on.
Well, I don't know, it's 90 degrees.
And it is 90 degrees. And what was the ordered pair up there on the unit circle at 90 degrees?
1, 0, 1.
0, 1. It does have an ordered pair. But it's not one of those in that table there. It's right on the circle, wasn't it? 0, 1. And if I ask you for the, I'm doing cosecant, it says place 1 over y. It looks like the y is 1 up there. And there's my answer. That's one that was outside the table, but was right on the unit circle. I'll try another one here, guys. Number 7, secant. It looks like I'm trying 3 pi over 2. And secant's definition is 1 over x. 3 pi over 2. Guys, you look back in the table and say, oh, Professor, it's not there. You get nervous. It's not there because it's right on the circle. Does anyone recall what it was on that unit circle at 3 pi over 2, 270 degrees, as ordered pairs? Was it 0, negative 1? 0 first. Is that true? And I'm looking for secant, which is 1 over x. So you're placing 1 over from that ordered pair. The x is 0. You're placing 1 over 0 right here. That's the x. So what's going to happen here? No solution. Undefined, they call it. Gradually leading you into this. Let's see if I threw in one more here. Yeah, I did. Number 8. Try one more here, guys. Cotangent 2 pi. Does anyone recall, before I place it myself, does anyone recall the definition for cotangent? X over y. 2. Now 2 pi is not in the table, it's right on the unit circle. Does anyone recognize what the ordered pair was at 2 pi? What was it? 1, 0. Got backwards. Is it 1, 0? If you look on the unit circle, was the ordered pair there 1, 0 at 2 pi, like 360 degrees? And I'm looking for it back here. It says place the x over the y. Well, the x is 0, wasn't it? And the y is what, 1? Or is that the other way around? Is the x one here? And is this 0? Yes or no? And therefore I ran into another what? Undefined function at that value. Wow. Is it making sense now? It's gonna make no sense unless you, I hate to use the word memorize, unless you know the definitions for these trig functions that we're working with. Okay, from yesterday. But is that table somewhat help? Sometimes we run outside, but we still deal with it even outside the table. Because the table, I think, is a big help. Now that said though, we're moving to part 2. I'd like to find the exact value for these, if I can. Find the exact value. You guys, I'm trying to make all this connect for us, like I usually do with my presentations here. This one looks like this. Sine of 13 pi over 6. Sine of 13 pi over 6. Now, if I look at the table, is that one of them listed in the table? No. 13 pi over 6, when you search that table, I don't see 13 pi over 6 listed anywhere in that table. Now, you said, Professor, if I don't have it in the table, what am I going to do? And no calculator's allowed. I can't really place it in a calculator and see on the screen what the answer is. Any ideas?
Yes.
Oh, let's see. Joseph.
It goes in whole circle, like around the whole circle.
So he wants me to sketch it first. I will sketch it to make sure I know where I am. He said, Professor, are you going to eventually get back to that table? I am. But Professor, if you eventually get back to that table, right now I'm not in the table, but if I eventually get back to it with some help from my students here, I see a pi over 6 involved. So maybe it'll take me back to here. Maybe. And then we deal with it, because I have the ordered pair for pi over 6. Now he says, Professor, sketch it. Guys, 13 pi over 6, we'll do something here a little, maybe you haven't seen before, but I'm going to sketch it. Could I, since this is a string one here, could I actually treat this like a fraction? And then do what he suggested. Actually divide 6 into 13 pi. Which will go what? 2 pi, that's 12 pi, just doing division. A little remainder of pi, which I could bring up here and write it like that. I did a little division, elementary school. And by the way, if you put these back together with the common denominator of 6, you'll get 13 pi over 6. So I could think of 13 pi over 6 as looking like that. So this is a sine of 2 pi plus pi over 6. Now, can anyone tell me as I sketch it? I want to sketch it. Think about that. Joseph, I think you already told me. I need to move 2 pi first, then an additional pi over 6. If I move a 2 pi, where does that take me? Or what does that mean if I move 2 pi? Full circle. Absolutely. 360 degrees. So guys, I'm going to just do it like this. Leave a little space there. Full circle, that's 2 pi. Now the reason I sketched it like that is I need to move an additional row from there. How much more? 5 or 6, which is 30 degrees. That's a small angle. If I move an additional 30 degrees, guys, will that push me into quadrant 1? So my angle is going to terminate here in quadrant 1 when I move that additional move here. Like that. And Joseph, I think that's what you were thinking about. It's one complete revolution with an additional 5 or 6 that takes me into quadrant 1, and quadrant 1 is the safest quadrant to be in. Why? If I need it, the coordinates are all positive. If you're in quadrant 1. I'm in quadrant 1, so I know my answer is going to be positive. I'm doing sine. I know sine is y. Are you kidding? Since this is what, 30 degrees now, I think it's 5 or 6, is it 30 degrees? Could I go back here and make a reference to this? Oh, it was a Y back here. Was that 1/2? So could I now say, with confidence, that my answer here is positive 1/2 for this? Yes or no? So even though these angles get fairly large, you can still maybe take them back to that table where the smaller angles were located and make a connection for me. Oh, you guys, this in degrees, let me do it real quickly. 13, 5, or 6. I'm standing here dividing this thing out, changing it to degrees. 30 times 13, I think it's 390 degrees. If you do it in degrees, it's 390 degrees. That's a pretty good size angle. But it took me back to that table. Let's try another one here. Joseph, you're helping me out this morning. Let's try this one. What's that? Next one looks like this. Why not? Tangent 22 pi over 3. Tangent 22 pi over 3. Which of those angles back in the table do you think this will eventually take me? The way it looks. No, which angle? Which angle? It's got 3 angles in there. It's pi over 3, pi over 6, pi over 4, or pi over 3. Which angle? 6. Pi over 3. I see pi over 3 staring at me. But it says, more likely, Professor, you're going to go back to pi over 3 over here eventually. But first I need to locate this. I'm going to do this again. I'm going to divide 3 into this like a fraction. I think this goes, what, 7? That's 21 pi. Do a little subtraction, have a remainder of pi. And we'll write like this. So guys, you can put these back together, the common denominator of 3. It takes you back to 22 pi over 3. Now say, Professor, how will that help? Well, I'm going to now sketch this using, let me do this and get out of your way here, tangent 7 pi plus pi over 3, I just renamed it. That's what I'm looking at. Now we'll use that to sketch it. I'm going to sketch this on the side and see where that angle is located. First, I'm going to move 7 pi. I got to show it. I got to show 7 pi movement on that grid. Well, you say, Professor, my goodness, we've already established that 1 complete revolution is 2 pi. There's 2 pi. I want 7. That means you're going to move an additional, another 2 pi. I'll connect it here and it takes me there. Is that 4 pi? Now, do I need another complete revolution also? Takes me at what, 6 pi, I guess? Let's move. An additional. That's better. There. It's all that together representing 6 pi. At this point. Is that 6 pi? 2 pi, 2 pi, 2 pi. I need, where am I? 7 pi. That means I need to show how much more of a movement. A complete revolution or just half of a revolution? Half of, so my angle is going to terminate, stop, right there. For 7 pi. You guys agree? Now, am I supposed to stop there and now calculate an answer? No, it says no, move an additional from there, 60 degrees. Pi over 3. So if I move here an additional pi over 3, 60 degrees, it's going to push me into which quadrant? So third quadrant, quadrant 3. Absolutely. I'm going to do it like this, guys, and show that now I am now down here, and the angle is going to look something like that. Whew. I'm in quadrant 4. That's the important thing. Now if I'm in quadrant, not quadrant 4, quadrant 3. Quadrant 3 has coordinates of what? Both negative. That's the important thing here. If I'm in quadrant 3, I better take note now. Yes, those coordinates are both negative. And you guys said since pi over 3 came out, Professor, and you're looking for a tangent, and tangent's definition is what? Y over x. And I should go back to, where was it? Pi over 3. I have that in the table right here. So if I place y over x, for that reference, I'm placing radical 3 over 2 over 1/2. See if you got it agreed. Radical 3 over 2, 1/2. And of course the 2's cancel and get radical 3. Is that true? Woo, after all that work. By the way, I got a positive radical 3. Should it be positive? Didn't we say it was a negative over a negative? If I'm down in quadrant 3, just turn it into a positive. It's a positive radical 3. Guys, I like this technique. So you can go outside but then come back to the table. Any concerns yet? Is it making sense? Okay. Letter C. Seems like I make myself a note here. Oh, I did. Letter C. One more here. Cosine. It looks like I have. I do. 11 pi over 4. Looking back in the table, I don't think 11 pi over 4 was mentioned. But since I see that pi over 4, I don't think it was mentioned, was it? Pi over 4, 11 pi over 4, no. But since pi over 4 is mentioned in this, don't you think it's going to eventually take me back to pi over 4 to work with? Joseph? Tell the class which quadrant do you think this angle, because it's going to play a part, is located if I sketch it. It says 30. Let's find out. Divide 4 into 11 pi. You guys will end up with what? 2 pi here? 8. Is that a remainder of 3? Yes or no? I'm running a couple of boards. Was it? So I'm looking at 2 pi plus 3 pi over 4. You guys agree? Is that another way to think of 11 pi over 4? So we'll do this. This can now be thought of as cosine of 2 pi plus 3 pi over 4. Yes or no? Woo! You've got to think about this one. If I sketch it, see which quadrant I'm in. Mr. Park. Guys, do me a favor if you have a calculator there. Go ahead and calculate, don't tell us what it is yet. See what cosine of 11 pi over 4 on the using the calculator is. We're doing it non-calculator. Just go ahead and do it and we'll check. Guys, 2 pi revolution, that would be 1 complete revolution. That's that. And then Philip, I think he says don't stop there, move an additional what?
3 pi.
3 pi over 4. Now, if this in degrees may be easier for you to move, I think 3 pi over 4 is what? 135 degrees in addition. So if I move an additional 135 degrees from here, please tell me, is it going to take me into quadrant 2? Beyond 90 and less than 180. So I'm somewhere in quadrant 2. If I move an additional 135 degrees or 3 pi over 4. So guys, the angle's over here. Markers are not working out very well today. There's my angle located. So I'm in quadrant 2. Let me point out real quickly. The coordinates in quadrant 2 are negative or positive. And we said, pi over 4 is staring at me. We said, Professor, I think eventually it's going to take it back here. Think so? But I got to be careful. Which straight function am I looking for? I'm looking for cosine. And cosine's definition is what? X. And I'm in quadrant 2. What do you think? Hang on now. Here's 5 and 4. In quadrant 2, I think we said the x is what? Negative? What do you think the final answer is based on what you see over here? Is it going to be negative? Radical 2 over 2? Because it's in quadrant 2, it's going to be negative. here, it's gonna be equal to negative, and back to my table, I see the x coordinate over there is that. Negative radical 2 over 2. Mr. Park, hang on just one second. Does the calculator show you negative 0.7 something?
It gives the same negative root.
Oh, you did like this, it gives you the same answer you see on the board.
Yeah.
Does it actually show negative radical 2 over 2?
Mm-hmm.
Oh, it does, with a negative sign.
Mm-hmm.
A radical 2 over 2.
Mm-hmm.
You guys like this little system? It works. Now, letter D. Let me step back and see what trig functions I've tried and tried something different. I've done sine, tangent, cosine. What would you guys like to see? Go ahead, let's do secant. Secant of, I'm gonna try secant of, hang on, let me think of a nice one here. Why not? 16 pi. Secant of 16 pi. And by the way, I see pi there, I don't think pi was one of those listed back here in the table. But maybe something unique is happening. Guys, the definition for secant she asked me to do was 1 over x. So know the definition. Now, 16 pi, I'm not doing the long division on this one. It does not require it, but I am going to sketch it. Now, a little common sense. 16 pi, one complete revolution is what? 2 pi. So that means, yes, I have 2 pi here. And if I move an additional revolution, another revolution, I'm now at 4 pi. Is that true? And then another 6 pi, then 8 pi. With that 16 pi, eventually take me right back to where I started, here. If I move a complete 16 pi. And if it does, and I'm back to where I started, guys, I think the point that we had associated with the unit circle at this point was, thank you. So that's one that did not fall on the table. I thought I better point it out though. And now she wants secant. Well, secant is 1 over x, and the x in this case is 1. So I got 1 over 1 is equal to 1. Mr. Parker, you find the secant of 16 pi? Of course. 51. Isn't that nice? Nice. PK. Was it 1?
Mm-hmm.
Now, if I ask you this, PK, find the tangent, let's say 2 pi over 5. I guarantee you if I ask Mr. Park to do it the way he's doing it, there's an answer. But for us, is 2 pi over 5 one of those in that table? I just have 3 over there. Is it one of those 3? No, 2 pi over 5 is not mentioned in that table. And looks like it would be awkward, if you know what, if I tried to divide it out to see where it is. 2 pi over 5. I could convert it to degrees if I want to see where it is. 2 pi over 5, guys. My conversion factor was, my conversion factor if I want to take it from radians into degrees. Is it 180 over pi? Yes or no? Pi's canceled. This I think is, help me out here, 5 into 180, how much is that, guys? 36? And twice 36 is what? Help me out, 72?
No, in total it's
30, 15, 18. Is it 72? Yeah, 72 degrees. I'm scared. 72 degrees. So this is equivalent to 2 pi over 5 is equivalent to 72 degrees. Have I mentioned 72 at all today? No, it's not one of the special angles. Does it exist? Definitely exists. Mr. Park, can you tell us real quickly what's a tan of, gotta use a calculator though, tan of 72 degrees? Probably give me an approximate answer. tan of 72 degrees. Now I have mine in degrees, I don't know whether you have your calculator in radians.
It's 3.0777.
3.077? Oh, I've never seen that before. You asked me, you walked, see the see me in the hallway at the break and say, Ramsey, come here a second. I said, what's going on? What's the tangent of 2 pi over 5? I don't know. I've had a lot of math. I have no idea. I have to use the calculator. So some of these you will not be able to do the way we're doing. So the special ones you will be able to do. So PK, I just called your name there. Good boy. Let's share the calculator. Oh, Lord. Okay, guys, we'll step back, look at it. Does this make sense now for a little recap, putting everything together? I think this is so valuable right here. Where you just follow the table and match things up. And all of a sudden you say, wait, Professor, you gave us a lot of examples here where I was outside the table, but it took me back to the table. And the quadrants to pay attention to work with. Okay, we step back. Any concerns at all? Okay. Now that said, you do all this erasing. I think it's nice. Seems like I left the space down there. I'll think about later on what I was going to do given the space. Right now we're going to see. And by the way, you guys who may not take the best of notes, boy, have you lucked out this winter session. June, have you seen June's notes? Wow. In June, the professor himself, I'm making copies. May I, you have copyright on this?
Yeah.
Should I sign for it or something?
That's okay.
Yeah, we use those notes. Guys, let me stop right here. Some space here. Okay, summary of trig functions. I think we did a great summary. Now, part 2. I'm going to list this as the trig. We abbreviated it. It's called trig. Trig properties. We'll get into graphing here shortly. Your textbook identifies these as, they use this word, the identities. Trig identities. Trig properties. And we already have them list some to show you how to use them. First one. Okay, first we recopy or recap the trig function from yesterday. Sine theta was defined as y. Cosine on the unit circle was defined as x. I need that first. Tangent, y over x. Secant, I'll pick up secant next. 1 over x. Cosecant, definitions. 1 over y. And I think the last one was cotangent. And we accept that as what? X over y. Well, those are the definitions we had from yesterday. Now, with that staring at me, here we go. Your textbook, all textbooks, will ask students now to go back to those basic definitions and now rewrite and come up with some identities, properties related to these definitions. Guys, does anyone see any relationship here that maybe you could say, Professor, I could sort of rewrite or say it a little differently than what you have on the side there on some of these trig functions? Does anyone see one that I could rewrite? That's what they want. They want a property. They call it a property. Identity. Yeah.
Tangent equals sine over cosine.
Hang on now. Tangent. Tell us why why did you say sine of a cosine?
Because tangent is y over x.
Right here. It's y over x, and y is sine, x is cosine, so why not think of it as sine of a cosine? Rather than walk around and saying a basic y over x. We're saying the same thing here. Does anyone see any other relationship that may be happening among those?
Cotangent.
Do we get
Cotangent.
cotangent? Now, we express cotangent by definition to be that. Then I could write this as what?
Cosine.
Cosine over sine. Identity. Number 3. Does one see something else? Be expressed a little differently. Just secant. And how would you express secant? 1 over, right now it says 1 over x. So I can express that as what now? 1 over an x, I think, was by definition what? Cosine? That's out of the way. There's nothing hard about this. Does anyone see another one? Cosecant, I'm hearing. And tell me how cosecant would be expressed. Now, I know it's 1 over y, 1 over sine. I got 1, 2, 3, 4. There's a few of these you may not, but I think, let's see if a student may recognize another one here. Yes?
Cosine.
A cosine?
Yeah.
Wait, I got cosine to be x. How are you going to express cosine?
Cotangent times sine.
Oh, I see what you're doing. Okay, I see what you're doing. You say cotangent over something?
No, cotangent times sine.
Oh, hang on. I got you. Hang on to that. We're going to be doing some of that later on. Now I want something just basic. If you see something just basic, there's somebody know exactly what you're doing. Besides these 4, does anyone see another relationship here that maybe I can point out right quickly? Yes?
Maybe tangent equals to secant over cosecant.
Secant over cosecant. Hang on now. I'm going to try it. Tangent. Arena. You're saying secant over cosecant? Hang on. You and Joseph are getting ahead of me. First, let me see if that's equivalent. Secant is equivalent to 1 over x. She gave me. Cosecant is what? 1 over y. She's saying, Professor, that says 1 over x divided by 1 over y, which means what? 1 over x times what? Y over 1. Does that give you y over x? And is that tangent? Look at that. Now what you and Joseph are doing is you're going to establish something for me later on that may not be listed among these basic ones. I love that. Joseph, what you're saying? Love that. And I like this one. Absolutely. It's true. It's absolutely true. It just so happens it's not one of those listed in your textbook as one of the fundamental basic ones. But what you gave was true. Definitely. Yes?
Arc
Do it again.
tangents.
No, arc. No, we're not going to inverses yet. We're talking about arc tangent. We're going to inverse. No, just basic. And you may not see. Till we get
Cotangent.
a cotangent. We did cotangent like this. Can we express it differently?
1 over 10.
There you go. These two are they? These two are reciprocals. Tan and cotan. Is that true, guys? So PK says professor is expressed like that, and that is one of those in the textbook as one of the fundamental. What Arena gave me, what Joseph gave me, I love. It's just not listed as one of the basic ones. Yeah.
Maybe cotangent times tangent.
No, that's getting a little bit more, I know what you're saying. Something a little bit easier. You might see.
Tangent equals 1 over.
Now, if you want to, I don't know whether they list that or not, I'll put tan like this. Let me put it on the side here. Are you telling me, Arena, that this that PK gave me could also be expressed like that? Aren't you saying the same thing, tan and cotan are reciprocals? Of course not, of course. Guys, I don't know whether you, I'm looking at myself, if whether someone can come up with something really straightforward and basic that maybe we have not written yet, because I think the others are mainly going to require a little work. Yeah.
Cosine equals 1 divided by, I don't remember.
Wait, cosine,
Yes.
go for it.
Equals 1 divided by sec.
Secant?
Yeah.
Secant. I'll agree with that. You guys agree? He says cosine, professor, is the reciprocal of secant, or secant is the reciprocal of cosine. That we listed earlier. Absolutely. Now, if you check in the textbook, I don't think they list that one, even though it's true. They don't list that. He said, professor, what did they list? And that's why they call them fundamental identities. Ones that they want us to look at in a textbook, and usually see in other textbooks. Guys, I've listed 1, 2, 3, 4, 5. I think altogether we'll have 8. And but I don't think the other 3 that are missing here, I don't think you can see directly what they might be, unless you've had some experience with trig and you know some identities. Does anyone think they know another one? I'll show you on the side here. On the side, please tell me, would you accept this? First, just for a start. In discussion on a unit circle. Would you say any point on a unit circle, if you're on a unit circle, I don't care what point you're looking at on the unit circle, if you square the x and you square the y, should you get a 1?
Yes.
If you're on the unit circle. Yes or no?
Yes.
Yeah, and I've erased my table, even those points I had back on the table. If you square those and add them up, you get 1. Yeah, if it's on the unit circle, you're guaranteed. Now, if that's true, this is what they do in the textbook. Say, hold on now. Cosine is x, and sine is y. So you're actually, in essence, saying, and they place it in this order, sine squared, then do this one first. Sine squared theta, then plus cosine squared theta is equal to 1. That's the same as saying, guys, x squared plus y squared is equal to 1. They're saying sine squared plus cosine squared is equal to 1. Would you accept that? Then, from there, you say, Professor, I thought you said there were going to be 8 altogether. Let me go ahead and write this one down. Sine squared theta plus cosine squared theta is equal to 1. Number 7, I'll go back to number 6, modify it just a little, and get number 7. Let me rewrite. I got this. And they want you to modify it and come up with another of their principal, fundamental identities. What do? They go back to number 6 and they do this to it. Divide everything, all terms, by sine squared. Both sides. And then rename it. So the first term is what? Sine squared over sine squared definitely will give me a 1. Now, can anyone give me a good name for that second term? It says cosine squared over sine squared with that modification, where I know sine over cosine back here is tangent. So what might I write that second term as? Cosine squared down here.
Cotangent squared.
Was it cosine squared over sine squared?
No.
Yeah. So what is it there? Cotangent squared. And then about 1 over sine squared, and it looks like we said 1 over sine earlier was this. So could I write that 1 over sine squared as cosecant squared? They accept that as another one of your fundamental identities. You say, Professor, what's the last one that you want to work with here? Number 8, they're asking me to go back to this. You guys gave me earlier, which definitely is true, and modify it one more time and come up with the last fundamental basic identity. saying, now go through and divide everything by cosine squared. And rewrite. Let's see what it looks like. Guys, the first term, sine squared over cosine squared. I know sine over cosine is this, tangent. So can I write that first term as tan squared? Second term, obvious, that's 1. Now, 1 over cosine squared on the right-hand side, I know 1 over cosine is this, secant. So I could rewrite that as secant squared. There's another tree identity. Oh my goodness, if you as a student don't get a sense of, this is getting heavy. This is getting heavy. This is way beyond 1 plus 1 equals 2. You gotta know those tree identities. And I have 8 listed, I think. Always try to use them here shortly. Guys, any concerns about how they came up with these identities? They call them the basic ones, fundamental ones. Arena, you gave me another one. I would classify that as an identity. It's not one that's listed as one of the fundamental identities. Joseph, same thing. Okay, guys, anything all there to look at? Ask about? Now, here's what I want to do. Arena, Joseph, you threw my lesson off a little bit today. I was going to use those, and I am going to use those in a different way than what I have planned to do in just a few seconds. I'm going to still use those. But now I got to come up with a different plan. On the side here, Mr. Park, these students in this winter class have motivated the instructor to change his plans. What do I want to do? I want to establish now new identities using these old ones, using these fundamental ones. I was not going to do that today. I was going to use them in a different way, which I will later on. Mr. Park, would you please, do you have a copy of the textbook? You don't have it online, do you?
I have last generation.
Okay, well, I'm looking for, and I don't have the textbook with me, I just want to look for, these guys are great. I was going to look for an expression and ask, with their help, is this truly an identity? In other words, try to prove it, establish it. And darn it, you move me into that, and I gotta do it. Before I move into something else. Hang on. What you guys have done, you've moved me into chapter 6, which I think is very appropriate right now. Then come back and do what I want to do. Mark, do you have it? Don't you Google or whatever you want to do back there, identities, and come up with, see if they, or establish an identity, and see if they have one there that we can work with.
Okay.
If you find it, let me know, then we're going to place right here and try to establish that, yes, it is an identity. Karina gave me one, but I think I sort of showed that one. It did work. Joseph, I think you mentioned one earlier also, didn't you? And I think, did we show that one? Think so? Yeah, I need one a little bit tougher. Because these guys have moved me right into it. Wait, I'll tell my colleagues what happened. No, I want something really tough this time, since you guys are a little ahead. Let's get away from the ABCs. We're gonna try something tougher. Mr. Park, you got anything there that you would write down for me? It says to establish, darn it. And I don't wanna leave it right now. Please do that for me. Gia, it's in chapter 6. They've moved into chapter 6. And it's establish an identity. Oh, you got one. Okay. Listen for me.
1 plus 1 divided by cotangent squared.
Wait, 1 plus.
1 divided by cotangent squared
Okay, now, okay, hang on.
equals 1 plus tangent squared.
1 plus?
1 plus tangent square.
Now, she said, Professor, that's also, I can establish this as an identity. It's not one of the fundamental ones. And I think what she wants me to do, guys, do this, establish. We're going to stay on one side. This is not an equation. Let me see the equal part. So they want you to stay on one side and show you change that one side and make it look like the other side and establish it. This one that you gave me, please tell me, did we not say that 1 over cotan, one of my students gave it to me, 1 over cotan, right here it is equivalent to tangent? Right? So could I quickly go to that term there, 1 over cotangent squared, and from this basic identity, could I rewrite that quickly as tan squared? And then those two sides match up. Is it true? Now you're done.
Those are the same with tangent.
Exactly, exactly. You're done. Finish. Gia, did you find that in chapter 6 or not? Because I know when I finally get to chapter 6, they have some nice ones. I like that one right there. It's good too. It's
What section?
oh my goodness. Try 6.4. 6.3 or 6.4. If my students continue like this, June, Mr. Park, take me to other chapter. We're going to finish the course early. Then move me into chapter 6.
Maybe we read it correct.
No, I don't want you to get too crazy.
Yeah, what's complicated?
No. So we'll stick with something maybe Gio will find for me. Oh my goodness. Hang on, guys. Now establish. You guys ready? This is what, when we finally get to chapter 6. Here's one. I'll give you credit for that one. This one looks like this. Secant theta. I had to do it since I was brought into this. Times sine theta is equal to tangent theta. And I think maybe that would serve as a nice one, just to get a sense of where we will be when we get there. So guys, I'd like to establish that that's also, thank you, Jim. That's an identity. It's not mentioned over here, but you'd like to show the two sides are the same. They don't look the same, but are they identical? Identity. If we have an idea based on what we did do, what could I maybe do here and maybe establish? Use something we do have over here and try to establish if those two sides really are the same thing.
1 divided by
Secant, right here, secant is 1 over cosine, so if you want to replace this with 1 over cosine from those basic identities, go for it. And of course, you still have on the side there times what, sine? And please tell me, is that sine over cosine? Which turns into what? Tangent. And you're finished. So if you just write, Professor, that's tangent. As long as I see these two sides match up, you're good. Okay? It just so happens we don't walk around and think of this secant times sine is equal to tangent, even though it's true, as one of these fundamental ones. But we can establish others if we wish. Okay, I'm so glad you guys brought me into this. Now, that's all I want to do with that though. Part 3, gotta watch my time here. I have just enough time to close this down with this problem. Hang on. Guys, I'm trying to follow your handout I gave you. All this handout's really good. given? Close down, take a break here. Sine theta is equal to, yes, 3/4. And this is given to me. Find the exact value, no calculator, of the remaining trig function. I'll just put the word remaining to save us from writing so much. Find the exact value of the remaining trig functions. So we'll give you one, and some information about it, and ask you now, can you find the other 5? Okay? I got a list of 5 that are missing. Right now, cosine's missing. Tangent is missing. Secant is missing. Cosecant is missing. Help me out here. Cotangent, I guess. Last one here is missing. Woo! One, two, three, four, five. Got cosine missing, tangent missing, secant, cosecant, cotangent. Are those missing ones? You know. Okay, right? Okay. Now, you've got to come up with a plan. And that plan is, please use the basic ones and find the values for those missing ones. Go for it.
So we see the quadrant 2.
Hang on now. So you're telling me there, be careful, Ramsey. This right here says you're caught between 90 and 180. So you're in quadrant 2. You're caught between pi over 2 and pi. You're in quadrant 2. That's going to play a part. Hang on just 1 second. And let me point out, since he tells me I'm in quadrant 2, these markers.
Minus and plus.
It is. That's what's going to play a part. Negative and positive. Now, which one of these, it's up to you, I don't care which one you find first, but you have to validate it. That means you have to tell me which trig function, trig identity, over here, where you're using to find it. Because you want to have something in mind for one of those 5 missing to find it. Yes?
We can use it like sinus is the angle in front of the side in front of the angle divided by hypotenuse.
No, I'm not going to hypotenuse and all that business. I didn't mention the word
We
hypotenuse.
can find first.
No, you're going into something we'll get in chapter 6. That's chapter 6. Good. Okay, you're telling me one of these right here, he says, Professor, cosecant has been identified as 1 over sine. In other words, these two are reciprocals. So cosecant and sine are reciprocals. PK, and Joseph, I gave you sine as 3/4. Are you telling me I can jump down here real quick and say this must be 4/3? Yes or no? Is that the relationship going on over there with sine and cosecant? Are they reciprocals? So right real quickly through that fundamental identity. Joseph, I think this is what you want me to do. Jump down to cosecant and make this what, 4/3? Markers here. Okay. 4/3. Hang on. Now, cosecant is supposed to be 1 over y. Right? And I'm in which quadrant? Just make sure quadrant 2. And the y is what, positive? So when I place 1 over y or do the reciprocal, does it stay positive? So I don't have to worry about sign there. And now the validation, Joseph, you gave this to me, here we go. I'm just going to put black markers, that's what I have here. I'm just writing down that we had established earlier that cosecant is equal to 1 over sine. In other words, they are reciprocals. That's the one we were looking at back there. Did you get that answer? That's like a little puzzle. We're going to do a few more of these after the break. Does anyone see another of these that's missing, that somehow I can use one of these that we've already established to come up with the value? Yes?
We can use cosinus delta,
I mean cosine theta.
data, equals to radical 1 minus sinus.
Okay, we've got to tell me which one of these you want to use.
That one to sinus.
These are the ones I have. These are the
Sine
ones you
squared
get to
plus
use.
cosine squared.
Okay, tell me again.
Sine squared plus cosine squared.
Can I use, where is it, this down here, number 6? Okay, here we go. So I hear a student say, Professor, find that cosine if you wish by using this established identity. And how? They gave me sine to be 3/4, I can put 3/4 in there. Glad, look at this. Do your math here, I think it's 9/16. So I need to move that to the other side, we should know what's going on here, we're trying to solve this. Guys got a 1, then move that 9/16 over, what's that? 1 subtract 9/16, help me out, what's left? 1 subtract 9/16.
7, 16.
Is it 7/16?
Yes.
Left over or not? Over here. Is it true, guys? Did you give it to me correctly? Let me make sure students see what's going on here. This is going to be cosine squared is equal to 1 subtract 9/16, which I think is 7/16. Hang on, I'm not finished with it. So far, so good? That's what I think I heard. And then you're going to do a square root to find cosine. And right now, I see it's like a little quadratic. We usually put plus minus.
Only nine.
And it's what? Radical 7 over what? 4?
4.
I think I sort of heard that earlier. Okay. Now, PK's ready for me. She's wait, Professor. You're in quadrant 2. You're going to call it between these two. So you're in quadrant 2. If you're doing a cosine, which is x by definition, the x is what? Negative? So you got prefix that answer with a negative. So here's not plus minus, it's only a minus. So this is a negative square root 7 over 4. Woo! Jeez. PK. I help her. Now, does anyone have now, I've got some still missing, and you gotta validate for me. So we validated this one by using this identity. We validated this down here by using this identity. And I need to erase a little bit so I get some room here. We got that much done. Now, does anyone see anything I can use for tangent, secant, or cotangent based on what we have over there to find their values?
I use tangent.
And which one of these identities would you use?
Just sine is divided.
As the absolute sine of a cosine. So on the side here, validation, tangent is equal to sine of a cosine. Sine, I gave you 3/4. Cosine, we just discovered a negative radical 7 over 4. That's sine of a cosine. Now, if you cleaned up, I see the 4's canceled. Can anyone give me, after you rationalize and clean it up further, of course, it's going to be a negative answer. Can anyone tell me what that final answer looks like cleaned up?
3 squared root 7 divided by 7.
Tell me again.
3 squared root 7.
3 square root 7, got you, 3 square root 7, over
7.
7. You guys need to be recorded. Other classes need to see or hear this. Okay, that's tangent done. And you give me the validation. Okay, guys, I have now, put this back here, -3 radical 7 over 7. Mr. Park, I'm asking you to check all these before we take a break here shortly. I'll use the calculator, but we're about to finish this up. Guys, got secant missing and cotangent missing. Okay, and we'll find secant, right here. And what would you use, which of those identities would you use to find secant? Absolutely. Secant is equal to, I'll squeeze it right here. 1 over cosine, one of the easiest ones ever, because really it says they're reciprocals. We found cosine earlier to be this. Be careful.
4 squared.
Yeah, it's gonna flip it over. You're gonna flip cosine over for me, it's reciprocal, that's what it says to do in that identity. Guys, if I flip it over, it's gonna look crazy. What's that, -4 over what? Radical 7?
Yes,
Now, what does that look like cleaned up?
4 squared, not negative 4
Negative.
squared root 7 divided by 7.
Love it, love it. There's another one out of the way. Oh my goodness, I'm down to my last one, cotangent.
This is the reverse thing.
Okay, so cotan can be expressed as, I'm here, you could express it, Professor, by placing cosine over sine. I think that's what you gave me, right? Okay, guys, here goes. To find that, I would be placing cosine, I'll put it over here. That was a negative radical 7 over 4. Man, what a class today. Sine is given to me. 3/4. 4's cancel. So it looks like I end up with a negative radical 7 over 3. See if you guys agree. And that goes here. Do we agree? Ooh, ooh. What a class. Mr. Park, when I had you in math 2, I thought that was a super class. Changed my mind. I think about a super class right here. Guys, some strange answers. Mr. Park, before we take a break, do me a favor. Students will not know what you're doing. Would you do this as a little check here, pay attention on something, guys. Do an inverse sine on 3/4. Inverse sine 0.75 and see what the calculator shows you. Let's have me check a few of these values. What does it show you?
I got 0.
No, inverse sine.
Sine
Do it in degrees.
Oh, okay.
Different ratings. Check a few of that for us.
48.59.
48.59.
Yeah.
Hang on now. Now this brilliant class, tell me, and I'm doing an inverse right now. I think our student mentions about arc tan or arc sine, that's inverse. I'm not doing that with you guys yet. He's gonna check it for me. The angle is supposed to be located here, which I think is supposed to be in quadrant what, 2? So this angle right here, the screen shows that, that's not in quadrant 2, that angle's in quadrant 1, isn't it? Okay, so I need to move over to quadrant 2 there. Park, take 180, subtract that. Guys, this is what we're doing here. And tell me what the size of the angle now is.
131.409.
Okay. Close to 131,
Yes.
like that?
Mm-hmm.
Okay, now do me a favor, then we'll take a break, because our students need a break here. Here goes. Take cosine of 131 degrees.
I got negative 0.66.
Negative 0.0,
0.66.
0.066?
No, it's negative 0.66.
66, like that.
Uh-huh.
I don't know, let's see where I'm from. Negative 0.66.
Mm-hmm.
We got this. Now, with the help of the square root key, would you find square root 7 and divide it by 4? I know the answer is going to be negative. What's square root 7 divided by 4 close to?
It shows square root 7 over 4.
You can't just find the square root 7 on the calculator and divide by 4 yourself? Just a basic basic, is square root seven. Oh, what do you get for square root seven divided by four?
Negative 0.66.
Now, I want those two to agree. Right, square root of 7 divided by 4 is close to 0.66. And he did all the trig for me, he says, same thing, professors, close to 0.66. Ah. Does this make sense, though, the way we approach this? With your help. You guys led me right into something I wasn't going to do, and I went ahead and did it. And then we got into something else also here to do. Guys, take your well-deserved break. You got 15 minutes. I'll see you at 2:15. Jeez.